a little bit about me. This is a talk about what is different between working at other companies and working at a hyperscaler, like, for example, Google. So let me give some background. I have worked 7 years at KPMG. Then I moved over to AD Computing, who are still here at this venue, which is awesome. I see some of my old colleagues there. And next to AT Computing is the old NLUUG logo, and that is because I was a board member for 12 years and a chair for 6 years, from 2000 to 2006. And then came Google. Image is, of course, generated by Gemini. And some of the images are generated by Gemini because I now, whenever I make a slide deck, I want to make sure that I use proper attributions for images. So I only use CC0 or whatever images, usually Wikipedia images. Or I can have them generated by Gemini, which is totally fine, right? Because no stolen data is in there. So, what is it like to work at a company like Google? Well, in my KPMG times, we had a coffee lady who would come by twice a day, twice a day. And at AT Computing, we had a small kitchenette where we could get coffee, and I would make tea because I only drink tea. And at Google, we have micro kitchens, and this is actually a micro kitchen in the Zürich office. I have used this micro kitchen. It is made like a underground. All the micro kitchens are themed, and what you find in the micro kitchens is basically what they had here. So snacks and soda pops and coffee and tea and stuff. And sometimes there would be extra stuff that makes... They say that the first half year at Google, you gain the Google 15, which is 15 pounds of stuff. And I must say, now that I no longer work at Google, and actually I have not worked at Google in all of April, I just took days off, and I was back in the office last Thursday, I actually lost some weight because at home I just eat a sandwich with cheese, whereas at Google, lunch was in the cafeteria like what we had today. And that's all free. Actually, a lot of stuff at Google is free. Free breakfast, free lunch, free dinner if you want to. It's even more than free, because the Swiss tax agency says, no, that is a form of income. And then Google says, so he has to pay taxes? Yes, he has to pay taxes. We will pay his taxes. So yes, there is something like a free lunch. There is hairdressers, you have to pay for that. There is laundry rooms where you can do your laundry, because in Switzerland everyone lives in a flat, and you have a shared washing machine, and that means that you have the Tuesday morning slot where you need to do your laundry, or you take the laundry to the office and do it in the office. Sorry? Did I have slides? Yes, we had a slide going down into the cafeteria. And we have massages. So what did I do at Google? When I started at Google, I was in the production monitoring site reliability team, which is responsible for all of monitoring at Google. And the main monitoring tool is something called Monarch, which stands for Monitoring Architecture. There is a link in the notes of the slides to the white paper about Monarch. It is humongously big. We will talk more about it later. So yes, I have walked around with the pager. I was not a good SRE. I am not a good SRE. I have imposter syndrome, which almost everyone has at Google. But also, it was just so overwhelming, I could not really handle that. And onboarding for SREs was not really good. Now, fortunately, I had a background in teaching IT stuff. Thank you, AT Computing. So at some point, there was a fellow Googler who did a lot of teaching stuff in the US, who happened to be in Zurich, and I just had gotten a complaint from one of my new teammates about how bad onboarding was, and I went to that other team member from the US, and I said, I think we have an onboarding problem, and you and I need to fix that. And that is how we actually created the unicorn team, which was SRE EDU. I'm the co-founder of that. The recruiters always said, what you want is impossible to find. You want top-notch software engineers, and you want top-notch sysadmins and system designers. That's impossible. You're looking for unicorns. So what we would do is we would get the unicorns that were freshly hired, and then we would make them go fast by putting a jetpack on their back. So that is SRE EDU. One thing I did while in SRE EDU is I was asked to read the manuscript of the SRE book, and one of the comments that I had is that there was no coherence between the chapters because they were just basically separate articles, and whenever someone did name dropping of one Google technology, they would add 5 sentences of what that really is in all the 20 chapters. So I wrote, you should have a glossary or have a chapter that describes the Google infrastructure. And they said, interesting. Can you write that? You have 2 weeks. But that is how I got chapter 2 in the SRE book. By the way, this is a copy of the SRE book. My Google colleagues, when we said farewell on Thursday, gave me another copy of the SRE book where they had written small goodbye notes all over the place. So now I have 2 copies of the SRE book. So if anyone could make me not fly this back to Zurich and take this off my hands, then we'll have to do a lottery or whatever. So one thing that is cool about onboarding at SRE EDU, Google has money and Google has volunteers. So what we did is we created an application, this application here. It's called the SRE EDU Photo app. It is actually sre-edu.photos-corp.google.com. So it is a perfectly correct Google application, just not usable by people who don't have the credentials. It's a very simple photo app. You can upload photos, you can look at the photos, you can click on a photo and see the main photo, and you can click on hashtags, and that's it. But we have put in what is called in German Sollbruchstellen. And a Sollbruchstelle is a thing where things should break whenever I want to. So we can just pull a lever and then the thing is broken. You get 20% RPC errors, and then the students have to go look at it. And in groups of 3 students, they get ownership of this application and all the processes that go with it, and they can investigate whatever they want. It is a true production service, and they fix it. Now, of course, we don't just have one of these. We have tens of these, so that tens of groups of 3 people get their own instance of this. And every instance, just to give you an idea, it's a proper Google application distributed. So we have a front end and a back end running on Borg, which is like the Kubernetes, but then in Google, just bigger. And it runs, of course, it has 5 copies of each of these programs running in 7 or so different data centers. So you get, in total, like 80 different applications talking with each other, and that's a lot of fun. But this is the crown jewel of SRE EDU, and it was all made by volunteers. Then I also got to write with my colleagues, and I still have a couple of copies of those left, a small booklet called Training Site Reliability Engineers. It's a booklet with O'Reilly. I have 3 left here, so if you're quick. And the final thing that I did is, and you may find this controversial or not, or cool or whatever, SANS is a joint venture by Thales, the defense contractor or defense company in France, and Google. It's a joint venture, and what they have done is create a Google data center with Google hardware, Google infrastructure, and then we handed over the credentials, literally, the root keys and everything, to SANS. And these are French people, and they have been approved by by French government to run French government stuff. So they are now a cloud provider in France that is completely sovereign from the US. The US has no jurisdiction there. Sure. Anyway, what I've done is I have been teaching the SREs that are going to run that data center for 4 years, and in the end, I had also trained their trainers, so they can now do it themselves. And the last thing that I actually really worked was handing over those keys to the training kingdom. So I'm quite happy with that. Okay, that's what I did. So what is it like to work at Google? Well, let's go to the top left. Work-life balance. Gemini created, you can see the faint yellow color. Work-life balance is good. I had a 40-hour contract, and I would work 42 hours a week. And if you work more than 42 hours or whatever, then your manager comes to you and says, maybe you should tone it down a bit. So yes, really good work-life balance, except SRE means that you have 2 teams in 2 geographic locations that together have the pager load so that no one has to be woken up in the middle of the night, usually in California and in Europe, or in Australia and Europe, which means that you have either very early or very late meetings. And I used to have late meetings on Mondays, Tuesdays, and Wednesdays, and I blocked my calendars for meetings after 5 p.m. But otherwise, usually on Mondays, Tuesdays, and Wednesdays, I would be having meetings until 7 p.m. That's not really fun. Travel time was compensated, so if I had to fly to the US, they said, well, you have to fly in the weekend, or you have to fly in on daytime, in working hours, but if that's not possible, then they will just give you back the time. So I think that's really, really nice. But I was in the SRE team, and the logo of SRE is this thing here. And that was scary for me. There are many people who think it is wonderful to be paged because that's a new puzzle to solve, whereas for me, it just gave me the creeps, which is why I have Monk's public domain by now. Image of the scream. For me, it was like that, and I'm very happy that I could actually move away from that. We have still a lot of fun at work. 20% stuff is still a thing at Google, and actually that photo app that I just showed was built by a couple of volunteers in hackathons that came to, in our case, Pittsburgh, Pennsylvania, for 2 weeks, 10 people working on that, and then 3 months later, yet again, 8 engineers coming to Sunnyvale in California for 1 week, and so on and so on. And then after that, we had people create breakages, where we would break the thing in a specific way, and that was all 20% work. So we have had many 20%ers work for us. There was one guy who made a really fun thing, just for the fun of it, not as a 20% thing, but just because he could. There is a link to a paper on the Google site. A guy created an application that generated metrics, and if you would point Monarch, our monitoring tool, their monitoring tool, sorry, it's just been a week, so their monitoring tool to it, it would show you Rick Ashley, the outline of Rick Ashley, if the graph was set to update once a second. So it was 1 frame a second, but that means that new metrics were being generated every second, and that's a very high scraping frequency. And it goes through the entire monitoring pipeline for that. So that was really cool. So yes, the work is great, and the pay. I will just say you should read the article. the trimodal nature of software engineering salaries, which talks about how salaries in different styles of companies are, very regional, countrywide, or the salaries of Google, Amazon, probably ASML, companies that have a recruiting pool that is basically worldwide. No complaints there. So, Google is humongously, incredibly, unbelievably big. And that is why we use many powers of 10. And let me go through some of them. So Zeta, of course, is what ZFS gets its name from. But exa, as in, for example, exabytes, I'm not going to name any numbers that I know from Google, just from external sources that are speculating about Google. But so in 2013, Randall Munroe of XKCD and What If fame, he wrote a what if episode. What if Google stored all the data it has on punch cards? And for that, he needed to know how much data Google had in order to estimate how many punch cards that would be. And he estimated 10 exabytes of data in 2013. The cool thing is, what Google did then, or engineers at Google did, is they made a puzzle for Randall Munroe with 2 layers of encryption, not too hard, of course, put that on punch cards and mailed that to him. And there is actually a series of talks at Google videos on YouTube. It's literally called Talks at Google. One of which is those with Randall Munroe, where he gives a talk at Google, where he explains that he got that letter in the mail with punch cards, and that with friends, through 2 weeks or so of work, decoded what was on the punch cards, and what the message was no comments. Okay, so petabit, that is normal. The Jupyter Data Center Network was described in a recent white paper that it has 13 petabits of cross-sectional bandwidth in a single cluster, or in a single data center. So continuous data flow of 13 petabits through the entire thing. So big numbers. Tera is trivial, because Tera is what it is called. So is Giga, trivial. Many applications use gigabytes of RAM. One reason is that most of the applications at Google are linked statically to prevent shared library hell. But yes, many use gigabytes of RAM, and of course there are several Google applications that have giga number of users. Kilo is so small, I have forgotten to count that low. You could say that's something Googlers say every now and then. But Google makes more than $10 kilodollars a second. Every second is currently, I think, $14,000. The 2026 Q1 revenue that was just published was $109 in 90 days. And of that revenue, 30% was profit. So big numbers. Milli is the land of latencies, of course. We count latencies a lot. It's very important that we look at latency, though. So milliseconds happens a lot. Micro, nano, yeah, that's all stuff that we all work with. So nothing really trivial, nothing really special. So Google is big. I have an image for you of how big. This is the campus of Google in South Carolina, near Charleston. It looks like a chip, don't you think? These things, they look like chips, but it's actually a data center building. This is what Google calls a campus, and a campus has multiple data centers. A data center is one single building, And a data center has multiple clusters. And a cluster is just a bunch of machines that are logically grouped together. So clusters inside a building. Building is a data center, multiple data centers in a campus. And these buildings are really, really big. Just to give you an idea, and I'm very sorry for the people from Amsterdam, this is the Feyenoord Stadion projected on one of these buildings. And I did the measurements on my monitor to make sure that the scale was correct and so on, and this is correct. So we're talking, I mean, from here to here is about 200 meters. So these buildings are all 2 by 150 to 200 meters. And if you look at the inside of that, on the left-hand side, you have a public data center photo from the data center in Giel in Belgium, near Mons, near Bergen. And it's just rows and rows and rows and rows of racks of racks of racks of racks of racks. This, if we zoom in on some of these racks, this is a photo from the data center in Eemshaven. Each of these is a tray, a sheet metal tray that has a main board on it with the computer, and that is just shoved in the rack. Why do you need plastic? It's just easier this way. And why is it easier? Because at this scale, everything is continuously broken. Just to give you an idea, Randall Munro's 2013 estimate of 10 exabytes of data, back in those days, a disk was like 5 terabytes in size. That means that you need 2 million disks. Okay, 2 million disks. If a disk needs replacing every 5 years, is that unreasonable? Okay, every 5 years you replace a disk because it breaks or because a new disk is cheaper. Then you need to replace 400,000 disks every year. Given that there are 30 million seconds in a year, you need to replace a disk every 75 seconds. And this is not just true for disks. The same thing is true for CPUs, for RAMs, for everything. So it breaks all the time. You need to have really easy access. But the notion of this is everything breaks all the time. Every big machinery in the world, there is always something that is broken. So how do we build for this thing, for this enormous hardware? Well, this is actually something that we call a large system design. And large system, of course, it is all microservices and et cetera, but large system design is thinking about what subsystems there need to be in your system and how they relate together. And this is from a white paper about Photon. And Photon is the log joining infrastructure at Google. Imagine a log file that gets appended to continuously for every ad that is displayed. And we have another log file that is a log file for all the ads that are clicked on. So you need to join those so that you know what you need to charge to the advertiser. And you can imagine that A, the volume is enormous, and the bandwidth that goes through that is enormous. So this is a large system design to do that. This is on the left-hand side, you have a very global idea of that infrastructure. Okay, now if we take this little box here that's called ID registry, you zoom in on that and you see that this is a number of shards, a number of copies that all work together, or not work together, but work in parallel for resilience and redundancy reasons. And each of those has 5 boxes that run the Paxos protocol. So that little box there is actually like 15 of those boxes, but if you zoom into one of these smaller boxes, you get this exploded view. So it just keeps going on with more zooming in on systems that are all working together. Everything uses RPCs and stuff, but this is really big. Now this is Photon. I have nothing with Photon, but I had a lot with Monarch. Monarch was the monitoring architecture that we use at Google. This is from the Monarch white paper. Important thing here is the leave. A leave is one single process that scrapes several targets for the monitoring data and keeps it in memory so that whenever someone wants to have a graph of that, it gets queried. And how does it get queried? Well, suppose you want to say, I would like to know what the CPU consumption is of my program blah, of which there are 5,000 copies running worldwide. So what do? Well, you send that query. So you need to get all the time series information, timestamp value, timestamp value, timestamp value, from all over the world. So all these leaves are told to give that data, and within a zone or a cluster, these leaves report that answer back to what is called a zone mixer, and then all the zone mixers report that data back to a root mixer, which mixes all that data together and does alignment of timestamps, so that if you say, I want to see the CPU usage per hour or per minute or whatever, you need to align that data. That's all done by the root mixer, and yeah, this is a big system. This is a very big system. Now, so this is talking about large system design, but actually, there is an interview type at Google for site reliability engineers that's called NALSD, non-abstract large system design, which is a mouthful. But what does the NA mean? Well, non-abstract large system design means that you get a diagram like this, and that you then have to estimate, okay, so how many disks are we going to need for this? How many CPUs are we going to need for this? How much RAM and how much network bandwidth. And the way that you do this is you look at your SLOs. So suppose that you need to be up at least 99.9% of the time, 3 nines. That means that you need to build in a certain amount of redundancy, because you know if a server breaks down, then a server needs to be restarted before the server can actually serve again. It takes 2 minutes because it needs to read a config file, blah, 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 blah. And based on that, you can do estimation about how many of these things you actually need. Also, based on the bandwidth that you will need, and how much memory is going to be needed, etc. And you can actually improve on SLOs even if you have worse underlying software. For example, suppose that you are a database service, and the storage system, and you need to offer 3 nines of percentile, no, you need to have 99.9 percentile of requests are responded to within 250 milliseconds. So if I query something from that database thing, then within 250 milliseconds, I will get an answer 99.9% of the time. But what if my underlying infrastructure can only offer 2 nines of that time? So I ask the actual hardware or whatever storage system is underneath that, and it'll give me back within 250 milliseconds, 99% of the time. But I need 10 times more of that. How do you do that? Well, you just store data twice in completely different locations, so you have no shared fate, and you ask the same question to both locations. The chance that you don't get it back within 250 milliseconds is 0.001%. So in other words, you now have a 4 nines service. So that is why your SLOs, your service level objectives, how reliable do I need to be, how fast do I need to be, etc., have a big influence on how much storage you need, how much CPU power you need, how much memory you need, etc., etc. And that is the thing that we do here. Note, when you dimension your system, you're often using something that is called N+2. And what does N+2 mean? Well, if you've done the math, so for redundancy reasons and resiliency reasons, we need to be present in 5 different locations. Well, then you need to be present in 7 locations. Why? Because one location may be taken down, whole clusters are taken down, for maintenance reasons, and one could get a lightning strike or something like that. So one unexpected downtime and one expected or scheduled downtime. You need to take care of that. So N+2 is a thing that we do in SRE. Now, Google internally is a tech island. And what do I mean by that? Well, when I started at Google, there was no Kubernetes, there was no Zookeeper, there was nothing of that. Now, that's 15.5 years ago. There was a lot of proprietary stuff out there that inspired things like Kubernetes and so on. And let us go past a few of these. Borg, also on Gemini created image, by the way. Borg is Google's cluster orchestration system. It was deployed in 2006. It's a bit like Kubernetes, except it can handle much larger scale, much larger, orders of magnitude. The next one here refers to Chubby. Chubby is a global locking service. So if you need to get access to some entity exclusively, if you do that in a single CPU with multiple threads, you just acquire a lock or a semaphore or a mutex or whatever. But what if one thread is running over there and one thread is running over there? Well, then you need some entity in the middle, and that is what Chubby does. And Chubby the name refers to a lock and safe manufacturer called Chubb, hence Chubby. Then we have Piper. Piper is Google's monolithic single repository. It stores billions of lines of code and is also used by a lot of automated processes. So if you make a little change with a command on the command line in, say, load balancing, then under the hood something is changed in the Google single repository for all of, When this was created, Git almost didn't exist yet. Everything within Google to communicate uses RPCs. And the thing under the hood, so the presentation layer for RPCs is called protocol buffers, which are a super efficient and heavily compressed and encrypted, of course, mechanism for creating structured data that you can send to the other side. The cool thing is it doesn't matter what language the client is written in, and it doesn't matter what language the server is written in. Basically, you make a description of your protocol buffer, you give that to the protobuf compiler, the protobuf compiler creates header files for different languages, and that header file is then included in whatever source code you have for that language. Very efficient, and it's used everywhere. And now comes the cool thing. Because everything uses RPCs, and not one team uses REST API, and the other team uses whatever XML RPC, and yet another team uses this. No, everyone uses RPCs. It means that we can do tracing. It is possible when you send an RPC out to flick on a bit, and that means that every server will trace that RPC and will set the trace bit for all resulting RPCs that go further down. So if I do a spanner write to the spanner database, then it will at some point need to do an actual store in the underlying storage facility, and that will also be traced. So in the end, what I get back is the entire call tree, just like you can do in normal single machine things, but over the entire call tree. You can see what the latencies are, where the latencies actually occurred, etc., etc. And this is only possible because everyone speaks the same language. And you can go from Go to C++, to Java, to Python. It all works together with these RPCs. And yes, monitoring is done using Monarch. Now, having all of this means that new hires need to learn a lot. And whatever you learned while you worked at Google is hardly usable outside of the world, except for maybe RPCs, because gRPCs are the open sourced version of RPCs. And of course, nowadays we have Kubernetes, which are kind of like Borg, except I notice that when I teach people that they just get confused because, actually I get confused. In Borg, a single machine that has a server that can start tasks, as we call them, is called a Borglet. And I think it is called, what is that called? Is that a pod? A kubelet. Okay?
That controls a node which starts pods, which are containers.
Pods are containers. So then a pod is a task. Yeah, and a job consists of multiple tasks. I mean, there's actually literally a Rosetta Stone of how you need to translate from one thing to another. So yeah, it's a tech island. You need to learn a lot new stuff, and it's not usable when you leave. So there's a lot of useless stuff in here. So a little bit about what changed in Google. Who knows what this is? Okay, when I joined Google, there was this project that was to be a Google+, and it was going to be Google's social thing. And we were, you got to use this. This is really cool. And, well, actually, it was cool. But, yeah, well, in the end, it didn't work out. And then the next thing was mobile first, as it was called. And everyone had to go to an Android bootcamp to learn how to code Android applications. Did that. Well, Android is still there. That's good. And now, of course, everything is AI, and a lot of AI has been incorporated in a lot of Google internal tools. And it's really, I'm not going to say like what I've read about other companies that they are counting how many tokens you are consuming, and if you don't consume enough tokens, then you're not using AI enough, because that would, I think, be stupid, just like counting K-logs, kilo lines of codes for a software engineer. Actually, Edgar Dijkstra said you should not think about number of lines of codes produced. You should look at the number of lines of code expended, because every line of code is actually a liability. But yes, AI is all over the place there now. Other changes? Automation. A lot of automation. When I joined Google, my Noogler project, a person who works at Google is called a Googler. A new hire at Google is called a Noogler. And a Noogler gets a Noogler project, which is like, here you have some project that you can put your teeth in, and you will learn as you go. And it usually takes like 6 weeks to 3 months in SRE. And the one thing that I got was, we want you to release version 1.13 of this monitoring software, not Monarch, the predecessor. And that was a lot of work. It took me 2 months or 2.5 months. Nowadays, that same thing is being deployed, updated everywhere, every week. The photo service that I showed you before is being updated every second day. So completely tested, built, canaried, the whole shebang, 3 times a week, fully automated. There is one problem with that. I love that. I mean, automation is good, and SREs are all about automation. But it creates a lot of distance between what is really going on and what you do. There are too many layers of abstraction. I used to use a command line thing to say, start a job that consists of 5 tasks in that cluster, and bang, it would be done. What you do nowadays is there is some config file in which you set the parameters, and then within 10 minutes, the whole thing will be read, and then it will be enacted. It looks a bit like what in aviation people call fly the plane, don't fly the automation. If there is an emergency in a plane, then the pilot needs to know how to use the stick and the pedals and stuff like that, instead of just turning a wheel. I would like you to go to a heading of 300 degrees, right? And that is a bit the problem. I'm worried that new hires don't know how to command Borg stuff, because the only thing they have to do is 5 layers up, change something in some config file, and it will just happen. So that's something that happened. Some change was also created by that little bugger there, COVID. We used to have lots and lots of students in our SRE EDU classes, like 30 in a classroom in 10 groups of 3, trying to find what was going on in our photo stack. But then suddenly, within a week, we had to do it all remote via Google Meet. And it's not fun. It's not fun teaching remotely. But we did the best that we could. Yes, and the crowd that you see over here, Google has gotten a lot bigger in those 15 years that I worked there. When I started, there were 30,000 employees. And last I looked at the quarterly results was 190,000 employees. So really a lot bigger, financially as well. In 2010, when I joined, they had, in a year's time, 29 billion in revenue and 10 billion in income, so profit. Now it is 403 billion for 2025, 160 billion in revenue. And if you do the math in per person, then it gets really scary. Now, back then, we had 1.2 million revenue per person and $430,000 of profit per person in 2010. Now it is 2.1 million in revenue per person and 836,000 in profit. So it's a very rich company. Another thing is Google Cloud. I am really happy. I put my Google hat on. I'm really happy with that Google Cloud is doing so well, because Google was an advertising company, and now Google Cloud was like 1% of what they really did. Now it is 20%, and it's growing more than twice as fast as other parts of Google, which means that you get a company that gets a more diversified income stream, which is good, I think, for a company. What else do we have? Yes, AI, of course. Yeah, I know. Oh, thank you. AI is really big in Google, and Google is the inventor of the T, the transformer, in ChatGPT, the T there, except they didn't want to publish as quickly as ChatGPT did, and Google got caught a bit by that. I think it's cool that Google has 3 Nobel Prize winners for AI work. One of them is for protein folding, has nothing to do with LLMs. It was something that they thought, the scientific community thought was impossible to do, and it took like a year to try to decode how a protein is folded for just one of them. Google did it, or Google Brain did it in a year and a half, and they had 240,000 or so of them done. So wow, that is truly amazing. And then finally, in this slide, working for Google and telling people, oh, I work at Google. In 2010 was really cool. People would say, wow, you work at Google? Now it seems that the love for Google has cooled down a bit. Yes, and that's sad. So experiences working at Google, somebody should do something. Actually, I have some stickers here that say somebody should do something. Almost every SRE has a somebody should do something sticker. As an engineer at Google, you're supposed to see a problem and fix it and not complain about it. So if you see a problem, you fix it. I saw a problem whenever I had to change the on-call schedule for my team. You had to do that in Pacific time. But the team was in New York and Zurich, and I had to think in Pacific time. Google Imperial Standard Time. So that is impossible. And if you have a sister team that is in Sydney, you have to think in a completely different way because their daytime, summertime, wintertime changes are different and they go the other direction. So what I did is I made a tool, a tiny tool, just a Python thing. You read the on-call file, the config file. You translate all the times to your local time zone. You edit it in your local time zone, and then it changes it back to Pacific time zone. And yeah, there were people, it's still being used, so that's cool. So you fix a problem if you see it. You escalate whenever you cannot fix the problem. Remember that I talked about SRE EDU? I talked to this one guy and I said, we need to fix this. So we created a plan. And then a couple of months later, I flew to California to have a meeting with the vice president of all of SRE in Google. You escalate to the level where the decision can be made. There is no use in going to your manager and expecting that they can say, yes, we should have something like SRE EDU. No, you go to the place where actually headcount can be allocated and stuff. And that is not punished, that is encouraged. Though I must say, probably the culture has changed a bit because COVID has also made sure that we don't fly a lot. And even though Google makes an incredible amount of money, it's also spending 180 billion this year on new data center stuff, which means that travel is not really a thing anymore. Another thing in the culture is, this is the old logo of SRE, and it says in the logo, spes concilium non est, which means hope is not a strategy. Hope is not a strategy. Everything is always broken. You have to embrace the failure and not be worried about it. It's not like, I just hope that it won't happen. It will happen. So that is something that I learned. N+2 we already talked about. And post-mortem culture, whenever something goes wrong, you write down exactly what happened and why it happened, what we can do to make sure that it never happens again. And whenever someone hits enter and that breaks all of Google, it is not that person that is to blame. It is the system that needs to be fixed. And that is very important. And then finally, personal lessons. I have learned that if you have a team, it is very good if you have a very diverse team. Someone who is super good at Java, someone who is super good at troubleshooting, someone who is super good at this, because together you can do much more than if you have 6 people who have blinders on, who are continuously looking in that direction, and if the troubleshooting needs to happen over there and you're all looking that way, that's not going to happen. You have to have people that are very diverse in that. And for that, it also helps if you build your network. Make sure that you know people in the company, not just in your office, but elsewhere, and that is how you get a better working environment and have more fun. And with that, we get to the end.
Okay, thank you. Thank you. I think there's just time for 1 or 2 quick questions before the beer starts flowing.
I will be where the beer is also.
Well, just the two questions then.
Nice presentation, and it reminded me when you were presenting about broken systems and so on, that I recently complained to Google about ads. You have this ads transparency thing, and nowadays people sometimes get infected by malicious ads from, well, in this case it was from China related. So I complained, and I just looked at what Google replied to me about this malicious ad, and it was an error-like message like, well, the ad is not available anymore, or some other error. Well, that might happen, but I know from a researcher that he complained many times with links to VirusTotal. So apparently the whole complaint system for ads is broken. Do you have any advice what to do? I mean,
well, I'm running into that kind of stuff myself now, because I'm moving from Switzerland to the Netherlands. And all I get to talk to at insurance companies and things like that are chatbots, and they only fix the simple things. But when I come with something complex, someone from outside the EU, Switzerland, moving to the Netherlands, they can't help you. There is no phone number. So I'm not saying this is what you say is a good thing, but I don't know about that.
Okay,
and I encounter it everywhere.
Yeah. Okay, so there's no process basically to... I was looking for a process to escalate a thing like this, because I know apparently this is a broken... yeah.
Within Google there are things like that. Whenever I would encounter as a Googler, I knew how... You know, I would just look up what is the ads quality team, and I would file a ticket with them. But I can no longer file tickets.
No.
So.
Okay.
Okay. Well, where the beer is, JC is around. I think you got something to hand out. Again, thanks again. It was a great talk. There you go.